function here. These functions, we're going to try and sketch a gradient function. Let me show you what I mean. So, where is it 0? Where is the gradient 0? It's 0 here, right? Okay, so right at that point, the gradient is 0.
I have my thing ready for you.
Okay, I'll get that in a moment. Right at this point, what is the gradient? Yes?
I don't have my notes. I had Jared's notes.
Oh.
Where did your notes go, Emily?
How did you do that? You don't even see
Exactly.
But no, we haven't written anything down.
The person watching this recording is going to be like, what the heck?
Yeah, I'll give you another copy.
We haven't written anything.
I don't have any.
What we have.
I didn't have that.
Miss, you're going to have to do a lot of editing.
It's okay. So, let's stay back on here. So the gradient function. Are we all okay with this? The gradient. Are we ready?
Yep.
The gradient at these 3 places is 0. Because, if you look here, it's 0. Okay. Right here, is the gradient negative or positive?
Negative.
Negative. So the gradient here is going to be negative. What about over this bit here?
Positive.
That's negative or positive?
Positive.
So it's going to be something like that. It's positive. I want you to notice this. See how it's getting more and more, it's getting steeper and steeper, so the gradient's getting more and more. But what happens here? It gets less and less and less. So what's happening is the gradient's getting more and more and more, but then it's getting less. Okay, what about here? Is that positive or negative?
Negative.
So it's going to be down here. Once again, it's not too negative, but then it's getting more and more and more. Then once again, it plateaus off. So it's going to look something like that. Okay, what about over here?
No, positive.
Another positive. So my gradient function is going to look something like that. So, so that's my gradient function. The important things to note there is, you must, at every turning point, your gradient function must cross the line at the turning points. Other than that, the only other thing that is important is that you note every time that it's negative, your gradient function is below the line. Every time that you note that the gradient is positive, your gradient function has to be above the line. So as long as it's positive, it's 0 there, it's 0 there, that's why I put it at 0. Once again, it's negative all the way, so it's got to be below the line, 0 there, it crosses the line, positive here, and it's above the line. Does that make sense?
Could you just say that before what you said, we note that, and then you said something?
Oh, okay, because you did miss out on that yesterday. What's the gradient right here?
0.
0. So that's why I know that the gradient is 0. I've put a dot there because the gradient at that point is 0. Now, I know that this stuff is challenging. I remember trying to get my head around it for the first time too. As I said, the important things are, whenever they're a turning point, make sure your gradient function goes through the x, or crosses the x line.
Why did you draw another line?
Sorry?
Why did you draw another line?
Because it's positive. Whenever then my original function has a positive gradient, my gradient function is going to be above the line. Whenever it's negative, it's going to be below the line. Okay, let's try another one. Maybe it will be a bit clearer when we do one more example. So this is B.
Look at that.
Once again, let's do the zeros first. Where is this function? Where is the gradient 0?
Right where you x.
Right there at 0, so I'm going to cross at 0. It's 0 here, so it's going to cross right there. What's this?
That's a positive.
Positive. All this way is positive. So So if it's positive, it's got to be above the line. So I'm going to draw above the line, something like that. Okay. What about
That's
here?
negative.
It's all negative. So I'll do something like that. Okay.
And then goes to positive.
Then it goes to positive. Then it's just got to be above the line. Something like that. So this is called the gradient function. And it kind of looks like a parabola. Does that make a little bit of sense?
Is that a gradient function too?
Sorry?
Is that other one a gradient function too?
Yeah, it was. I just didn't label it gradient function. Yep, it's gradient function. Okay? They don't, yours doesn't have to look exactly like mine as long as wherever the gradient is positive, it's above. Wherever it's gradient 0, it crosses the line, and wherever it's negative, it's below. Okay? Now, that being said, let's go back to your notes, and you'll be very glad to know that we now have some rules to find the instantaneous gradient with these rules. I just rub this off. These are called the short methods of differentiation.
Will these
And
do nothing?
on your formula sheet.
Yeah.
That's a good question. I don't quite remember. Let's have a quick look. What is on your formula sheet? I don't. Yes.
Yay.
These are on your formula sheet.
Thank the Lord.
They are on there. They're under derivatives. So these rules are on there. They probably won't make much sense until I explain how they work. Okay. Here's an example. So the first rule says that if you have x to any power, what happens is whatever that power is, you times the front by that power and then minus 1 from the power. Okay, here's an example. X to the power of 5, the 5 goes down the front. 5x, what's 5 minus 1? 4. So my gradient function is 5x to the power of 4. Okay, 5x to the power of 4 is the gradient function. Here's another rule. So this next rule says that if my function is just a number, the gradient is 0. Why is that? Well, let's see. Just say, here's my xy, yx. So just say my y equals 4. What's the gradient of that line? 0. So whenever you have function equals a number, the gradient is always 0. So in this case, y equals 3, the gradient is 0. Okay? I want you to notice something. This is new notation. F of x you know to be the function. See how we have the little dash after the f? That little dash is now talking about the derivative function or the gradient function. So you might want to make a little note here. So this notation means the derivative function or gradient function.
Does derivative and gradient mean the same thing?
Okay, well the gradient is what the actual effect it has on the graph. The derivative is after you've done differentiation. So what we're doing right now, our method of finding the instantaneous gradient we call differentiation or finding derivatives. So they're the terminology that we use. Okay, but it all comes back to finding instantaneous gradient, which is the process is called differentiation or finding the derivative. Yes?
In the first example, where
Yes.
did the 4 from?
4, okay, the rules tells me that whatever my power is, I bring that number to the front and I minus 1 by it for the power. So that's just what the rule states. Okay? Okay, so we've done the rule 1b. Now let's come down to the next rule. And to have it on your formula sheet is awesome because you don't have to memorize them, you just have to apply them. Okay, rule 2a says, okay, if you have a number out the front times x to some n, what happens? Well, it's almost the same as 1. You times n by the number, and then once again you go n minus 1. So it's just a slight variation really on rule 1. And like the last here. Okay, so in this case, we have y equals 3x to the power of 4. I'm going to use this, so I'm going to go 3 times 4 is what? 12. X, what's the power there going to be, do you reckon?
4 minus 1.
3. 4 minus 1 and 4 minus 1 is 3.
Why
Okay.
does this one say dy over dx?
Great question. Do you remember how in the video we had yesterday, and Connie, I recommend this on Landscape, there is a video, that was an introduction. It said how those very small values of d, or infinitesimally small values, we call dx and dy. So really this is saying, this is a gradient, the difference in y over the difference in x, dy dx.
So it's the same thing as the fx.
Same thing. Okay, I reckon people get scared about calculus. The rules are not that hard. I think the hardest thing is just it's got a whole new bunch of symbols and terminology. So every time you're stuck with something, ask, and I'll try and make it as clear as I can. So to say dy dx is the same as saying, it's the same as saying that, and both of which are the instantaneous rate of change or the gradient function. Okay?
So they're exactly the same.
Exactly
So
the
that
same.
equals that. That's correct.
They're the same. 2 ways of writing or saying exactly the same thing. Okay? Let's now come down to 2b. Now, these notes have been written in such a way that every question has it written slightly different with all the slight variations of terminology. So this rule says if you have a to the ax, then when you differentiate it, you simply get a. So you get just the coefficient of x. Okay, so if I was to differentiate this, 6x, I would just take the coefficient, which is 6. Okay, this is another way to say the same thing. The way that you read this is you differentiate 6x with respect to x. That's how it's often said. As I said, there's so many different ways of saying the same thing, and I want you to know they're all the same. This talks about the gradient. This is differentiating with respect to x or the gradient function. This is saying exactly the same thing. This is telling you to do exactly the same thing. 3 ways now. Okay, so you've got those rules. We've got one last rule here, and then we'll do a couple of examples. Yes, we've got time. So this rule now says, if you have multiple functions together, plus or minus, simply differentiate them all individually. That's all it's saying. You've got a couple of different ones separated by plus or minus, you differentiate them individually. Let's try and do this with this example. Okay, let's see how well you can already do what we've done so far. What would that become? Only look at the 5x cubed. What would that become?
Wait, what rule are we using?
Okay, go back to your rules. What rule do you think you would use?
Oh, you'd minus 1, so it'd be, wouldn't it be 3,
Okay, you're right.
15?
Okay, so you times, you're right. You go 5 times 3, which is 15.
So would it be
X
15 squared?
15x to the power of 2.
Perfect, you've done it. And what rule was that?
The
One.
first one.
Oh,
1B.
Something like that.
Something
No,
like that.
it was,
I don't.
First one.
it was rule 1A.
1A told you that part, but if there was a number in front, it's actually 2A.
Huh.
Well, I just used my mathematical knowledge.
Oh, did you use your toolbox?
Okay, next
For
one.
those of you on camera, the toolbox is located on the right of the classroom.
Very good. Okay, back over here.
So they're in this
Justin. Could you help me with this one? How would I differentiate this?
It's the same as the last one.
Same, exactly. So what would it be?
14x.
So minus 14x, right? Is there any number after the x there?
Oh.
No, because it's 2 minus 1, which is just x. To the power of 1, which is x. Okay, minus 14x. Now, if you have a number in front of x, you just take the coefficient,
So
right?
it's just 6.
Plus 6. If you have just a number by itself, what happens?
It just stays the same.
Really? You sure? Oh, it's just a number by itself, it vanished, didn't it? Because the
It becomes
gradient...
0.
0, so we just leave it.
Oh,
And
is
then
that a quadratic?
So now that becomes a
Trinomial.
quadratic.
Is
Yes.
that a trinomial?
No.
Yep. Quadratic trinomials. Now another thing I want to point out here. With this one, this rule is really going back to exactly the same one as your very first one, rule 1A. If I went, okay, this is x to the power of 1. 1 minus 1 is?
0.
Anything to the power of 0 is?
Nothing.
One.
Oh,
That's exactly 6 times 1, which is 6. So really, everything is just a variation of rule 1A. So everything we've done so far is a variation of whatever's here, you bring the number to the front and minus 1. Okay? Now, as it says, it's important that you remember your indices rules. The only reason being is that now that we're doing some of the indice work as part of the rules, it does just help if you remember these. For example, anything to the power of 0 is 1, etc. So that is stuff you've done for the past couple of years. Brush up if you're not super strong on it. Can we come now to example 7.6? Here.
This booklet isn't very big.
No.
Fun. Is that everything for the whole topic?
Yeah, should be.
Wow.
Okay. We're going to apply just what we've done so far. So I'm going to differentiate. So we all got this? 7.6 example booklet. Okay, so I'm going to do exactly the same thing. So, we'll first differentiate the first one. So I could say
Won't it go so 7 times 3, which is going to be 21?
Yeah.
So it will be 21x to the power of 6.
So I could say it this way. The simple way is to just put a dash after it, which is the differentiation. Okay, so y dash is 21x6. Okay, what will this one become?
It will just become 3.
Minus 3. And the 2, any whole numbers go. So I've differentiated that one. So that one wasn't too hard. This next one, okay, let's do it. Y dash, 4x, we just take the coefficients.
So it's just 4.
4. Okay, minus 2 times minus 2.
Negative 4.
You sure? Minus 2 times minus 2 is
Plus 4x.
plus 4x. What?
It's There's nothing. You've
Minus 2 minus 1 is
Minus 1.
minus 3.
Question.
Or I could write this another way.
Don't you do it as a fraction.
Equals plus 4 over x.
That's not nice.
Oh, because.
Going back to the rules.
Fractions are
Like
Miss,
that.
will you still get it right if you do it as the first one? Or do you
Yes,
want
if
to-
you do it like that, you get it right.
Okay.
What's the number?
Good, because I won't be putting it as a fraction. No.
Let's come down to a few more.
Wham, bam, bam.
Cute. Is Linda ready?
Linda's in Melbourne.
Are you gonna put this video on
Does she
later?
I will.
Anytime.
Will it load up there?
We'll try.
What did she even do?
Okay.
Conference organizer.
If I can't, I'll find a way to do it.
Yeah.
So y dash equals. Okay. Let's think about this one.
Well, we need to have a look at it. This
So
is
times 3 to the front, 3x squared over 4
Wait, what are you doing?
minus 3 over 2.
What?
So what I've done is, remember that this x to the power of 3 over 4 is the same as saying a quarter times by x cubed. So all I've done is brought the 3 to the front, 3x squared over 4.
So you just
Doesn't that-
did it
Doesn't the number at the
above.
bottom of the
And then
like
it's
3x over
minus
2, doesn't that 2 cancel out?
No, because that's a square. If that was a 2 there, it would.
No, the 3 over 2. The 2 should have cancelled out, shouldn't it?
Why?
Gone to 0 because it's on its own.
Because that's on its own, it's got no.
Oh, no, because that is, okay, this is another way of saying, let me write this a different way. Y equals 1/4 x cubed minus 3 over 2x. So here, the coefficient really of x is 3 over 2.
Okay.
That's why.
So then when it's on the top, you bring your 3 up to the front, 3 minus 1, which is 2,
Yeah,
and then you get rid of your x, so you have the coefficient.
you've got it.
Do you go any further with it?
That's all you can do. Done. Okay, the next one. With this one, let's expand it out first.
Oh, yes.
Actually,
A difference of 2 squares.
2x.
what?
Are we going to get a difference of 2
Oh,
squares?
not quite. So
Oh,
y equals, let's just expand it first, x squared minus 6x plus 9. Now we can do it. So y dash equals
2
x squared becomes
2x
2x. Minus 6x becomes,
minus 6. And 0.
are the other 0 and we're
I
done?
can math.
I'm gonna end up
Yeah.
writing
How good's that?
All of the listeria.
Okay,
I'm sorry, what?
this next one. Now I know it looks like you can't.
Why is x squared 2 plus 0?
Oh, because I bring the 2 to the front, and then 2 minus 1 is 1. So it's just x to the power of 1.
Oh, yeah.
Yeah.
Listeria for one.
Okay.
Okay.
5. I know it looks like 5 is beyond what we can do, but let me show you. We can do this.
mean.
I could cancel an x out of each of these terms. So y equals, I brought an x out, 4x squared minus 2x 4x. Right? All I've done is I brought an x out the front. Are we all happy with that? So my x cubed is now x squared. X to the power of 5 is now x to the power of 4.
And then you just cancel. So
Now I cancel the x.
So
So
if
it's
we went to the
really
next
y equals 4x squared minus 2x 4. Now it's something you know how to do.
What if you
Does
did
this not work?
it the other way before?
Oh,
Well,
So you
I
had
like an idiot.
12x squared minus 10x squared on x.
If they weren't square.
So if you did the rule first, before you pulled out
okay.
x term.
No. Later on we're going to find a quotient rule. So what you actually do with fractions, it is quite long and complicated to do it. So whenever you've got a fraction for now, see if you can cancel.
Okay, no.
later on in this topic I will show you a way to do harder
We
fractions.
solve the rest of this.
Okay, now we'll do y dash. Let's differentiate this. So
8.
that's 8x
Just
minus
minus
8x
cubed.
cubed.
So you just cancelled the two x's.
Yeah, I cancel
And
x
then-
and x out, you can cross it out very well.
It's gonna be 0.
Who thinks that once you know those rules that this part is fairly straightforward? I actually think differentiation was one of my favourite parts. It's one of my favourite parts of the course because I actually think it's fairly easy. As I said, the hard part is the notation. The notation is confusing to get your head around. So whenever you're confused with that, ask me. I'll try and make it as clear as I can. Following the steps isn't too hard. Okay. Oh, this one now is a bit harder. Y equals 5 over x. I don't want to have to use the quotient rule. We haven't done how to do with
Wouldn't
fractions
it
yet.
be 5x
It
to the
was
power of
actually
minus
thought
1?
these were easy.
Is it 0?
Okay, hang on. Look at that. How easy is it now?
Whoa.
So it's minus 5x to the
Y
power of
dash
minus
equals minus 5x minus 2. Done.
You were almost there.
You were.
Close enough.
You really were. Okay. Or you could just leave it like that. Or
So
actually,
we
that would
don't
be the same as we could do it or minus 5 over x squared.
No, we're not
So,
doing that.
question.
Yes.
No, wrong answer.
How can you end up when you start with a -1 as the power and then get a -2?
Because what's minus 1 minus 1?
This is 4, guys.
I'm a reader.
Ready,
It's
Zach?
okay, it's okay.
Jane, ready? Here we go. I got you.
No,
You
I know
gonna
what
show
you-
it?
I know what
You
you
show
mean
it?
now.
Okay.
I
We're
just
here,
want
we're
stuff
here
now.
at -1,
Yep.
and then we're going back another one. So now we're at -2. So that's our power.
Oh, perfect. Thanks, guys.
See?